Hi everyone, I hope you all are doing well and welcome to day 8 of Array and String Mastery series for your placements by Aarush coaching classes. So we have covered so far too many topics like the how you can work with array 1D and 2D with the traversals. Then we covered the two-pointer technique, then sliding window. Among that, it was both fixed and variable. And then we have covered the hashing pattern till now. So now today we are going to level up from 1D to 2D arrays with two classic problems that are going to test your systematic thinking and optimization skills. So after solving it, you will know that you have mastered both the problems from today. Okay, so let's try to understand today's challenge first. So from 1D to 2D thinking, problem one, we are gonna discuss about product of an array except self. It is an advanced kind of 1D optimization problem where you're required to have the or give the solution in an in-place way, means no extra space, and yet the time would also be linear, not polynomial. Okay. And problem number two also, rotate image, systematic 2D transformation. Here also, though it is a 2D matrix, so obviously to traverse all the items, mostly it is going to take out of n square or out of the matrix time. Okay. But at the same time, the space optimization needs to be there. It needs to be in place for the solution to be optimized. Okay. So common theme about among these two are gonna be both needs to be solved as in-place operations with in-place operations and mathematical thinking. So obviously optimization के बाद चल रही है मैथ ना आए थोड़ा बहुत भी ऐसा हो नहीं सकता राइट सो बेल्ट्स कसके पकड़िए बांध के रखिए एंड लेट्स स्टार्ट टुडे ओके सो व्हाई these problems matter. As you can understand, optimization की बात चल रही है. We are talking about optimization. We are talking about transformation from 1D to 2D. Okay. So obviously these are mostly focused around do what the companies actually ask. FAANG frequency means how frequently it has been this kind of questions has been asked in the FAANG interviews are mostly around 70% plus for array focused interviews. Then skill progression would be builds on prefix sum and pointer manipulation. As you can say, prefix sum is all about a little mathematical pattern, है ना? तो वहाँ काम आता होता है and वो आपको use करना होता है. Real time applications are image processing, data analysis, system optimization, too many high level things. But let's stick to the fundamentals for now. Okay. So let's move to the first problem. First, which is product of array except self. As the name is suggesting, product of array except self. So you will be given with an array of integers named nums. You need to return the array answer such that, I mean, this is also an array, okay? So they are already giving you the liberty of taking an extra array to return the result. But that does not mean that this you are directly counting it as the extra space, you know, because in the question they're gonna mention what you are gonna think about it. Okay, so such that answer I is equal to the product of all elements of the array nums except nums I. Don't get confused, and I will show you. So let me read the constraints first. You cannot use any division operation because अगर division होता तो ये प्रॉब्लम होती ही नहीं फिर बहुत ही easy होता. We could have solved it in a very easy way, but we cannot use the division operation, so we must solve it in order of n time linear time. Space complexity, now here they have written should be order of 1 excluding the output array because they want the answer, because the answer is gonna be for all the items present in the input array. So that's why they want the answer in an output array, but you should not consider it in extra space. Other than this, if you're using any extra array, that would be counted in the space complexity. Other than this, any extra array used would be considered as extra space in space complexity. Okay, so let's start the to understand the question a better way. Let's see, let's talk about this particular input. If an array named nums is given to you and have items 1, 2, 3, and 4. So what does the problem statement actually talks about? They say product of array except itself. And here they say in the answer array for every ith index which should be equal to the product of all elements of the nums array except nums I. Means if I were to mark these items with indexes, then if I were to put the result array, na? Let me make one more array. This is result array. Obviously, this would be of the same size as the input array because you need to put I answer. I guess I give answer for all the items in the array. So here answer I is equal to the product of all elements of nums except nums I. So result I or let's say answer I लिख लेते हैं इसको. Okay, answer I is 0 right है ना? I को 0 कर लेते हैं. I 0 means what are the items that are gonna be included in the product of all elements excluding 0 है ना? Except nums I is 0 so nums 0 would be excluded. Exclude nums 0. ठीक है, तो क्या करेंगे? 2 multiplied by 3 multiplied by 4 equals to 24. That's what they have written here. Answer 0 equals to 2 multiplied by 3 multiplied by 4. I think multiplication is not given here directly. So let me just fix this. These will be 2 multiplied by 3 multiplied by 4, 24. Then for here 1 multiplied by 3 multiplied by 4, 12. 1 multiplied by 2 multiplied by 4, 8. 1 multiplied by 2 multiplied by 6. So 3 would become 6. Okay. Let me show it to you properly. So 24 आ गया. We'll put 24 here. Next, for I is equals to 1, क्या करोगे आप? What to exclude? Obviously, nums I. So nums 1 would be excluded. अगर मैं 1 को exclude करता हूँ तो 0, 2 and 3 would be included. So 1 multiplied by 3 multiplied by 4. Items at those indexes. Okay, so 4, 3 and 1, 12 would be. That's why 24 was there. Now here it is 12. Okay, done. Now for I is equals to 2. What would we be excluding? Nums2 would be excluded. So if I exclude this item at index 2, what are the rest of the items? So 1, 2 and 4. So multiply them together. 1, 2 and 4 will give you 8. Okay. So 12 ho gaya tha, now put 8 here. You can see 8 is here. Next, for third index, I is equals to 3. So we should be excluding nums at 3 in third index. Okay. Third index है 4 है. We should be excluding it. Rest multiply. So 1 multiplied by 2 multiplied by 3 would give you 6. 6 here, and you can see 6 is here. So what is the output? And the answer array 24, 12, 8 and 6. 24, 12, 8 and 6. Yes. So that's all this problem is all about. Now it's up to you how you can solve it, right? Because there must be some reason why this problem is considered to be most frequently asked in most of the FAANG interviews. Okay. So without this array, okay, I mean excluding this array, you don't need to use or you can't use any extra space to reach the solution. Now just take 10 seconds and think about it and write in the comment what approach would you like to go with. I know. Meanwhile, I will show you the different examples which are given here. -1, 1, 0, -3 and 3. So for this very first index 0, what is the multiplication of rest of the items? 1 multiplied by 0 multiplied by -3 multiplied by 3. So this will become what? What? Because 0 is there, so it will be 0. Hai na? Everything would become 0. For this one also, exclude 1, include rest of it. 0 is there, so 0. Okay. Now for the item 0. Exclude 0, multiply rest of them. So it will become what? 9. 3 times 3, 9. Though it is going to be -9, then -9 multiplied by -1, 1 and 1 again 9. Okay. For this also it will become 0 because -3 would be excluded, but 0 is there. So 0 multiplication 0 ho jayega. For 3 also 0 would be there. So that's our output. For if there are only two elements, so obviously they would be, I mean, you can say swapped. Look like they are swapped, but obviously for one, two would be the answer, and for two, one would be the answer. That's why two and one हो जाएगा. Okay. So now I hope you have got enough time to think about the solution approach. So let me show you what it can be. Most brute force approach would be yes, pick that item. Okay. Instead, let me show you. Pick the item. Let's say one है, 0th index, first, second, third. Okay. And take one more loop to multiply it with the rest of the items excluding itself. है ना? क्या लिखेंगे? Pick an item, multiply with because nahi, the better way to say this would be for every item. Yeah, for this will be more you can say appealing enough. For every item, product or multiply rest of the items except the picked or fixed item or fixed item itself. Okay. So what you can think of is let's say मैंने counter loop लिया 0 से I'm starting I less than n I plus plus. Now what I'm gonna do? I'm gonna take product prod equals to 1 because we are gonna multiply. We can't take 0. Initial 0 होगा सब 0 हो जाएगा. Okay. So take another inner loop. J is equals to ये कहाँ से start होगा? Obviously from the beginning, not from the I. Okay. Because you need to multiply with the rest of the items. Correct. Take the product of rest of all the items. J plus plus and then here what it will do if I is not equal to j. Okay. I j के equal नहीं होना चाहिए. Then what it will do? Product multiplication equals to nums j. That's what we are gonna do. That's how we'll get the product of the multiplication. Here also you can see I equals to 0 multiply indices 1, 2, 3. So items are 2, 3, 4. If I multiply them, so it will become 24. है ना? That's how it is gonna be. So I think I should put proper multiplication symbol here. Then only it will be very clear to you. What are we doing here is so 2 multiplied by 3 multiplied by 4 and here 1 multiplied by 3 multiplied by 4. Okay, and here 1 multiplied by 2 multiplied by 4 and here 1 multiplied by 2 multiplied by 6. Okay, that's what is happening here. So let's see the code quickly. I think this was a quite an easy solution for this and for you also to digest because we have been doing such kind of problems and the brute force approach is more like up to नींद में भी कर सकते हो, right? So here you can see the array is taken in the input. We are going to return an array itself. So we have taken the length of the array as n. We have created the answer array also. Now what are we doing? For each position, calculate product of all other elements. So that's why outer loop is for a particular fixed element. Then product we are taking as 1. Multiply all elements except current. So what are we doing? We're taking the inner loop where we are putting if j is not equals to I, then product means multiply that item at that index with the product variable and whatever item is there kept initialized with 1, so we'll get proper value. And once things are over for this particular loop we are putting in the in the answer array on the position I, okay, the value of product, and after that we are reiterating this outer for loop, and in a for loop it's continuously calculating the product only. And at the end we are returning this answer array of ours, है ना? So time कितना लग रहा होगा इसमें? What is the time complexity for this? Of course it is big of n square, है ना? because of this thing. Every item ये loop पूरा पूरा चल रहा है. Okay. And space complexity, it is constant because we have used variables only, few variables, excluding, let me write, excluding output array, which is answer. Okay, which is mentioned in the problem statement already. So why this is an inefficient? Odd n square. कौन चाहता है solution on a 1D array? Correct. So for each element multiply n minus 1 elements. It is repeated calculations. Same products calculated multiple times. Obviously, we are doing that. No optimizations doesn't use prefix suffix pattern. ये क्या होता है? These are some mathematics patterns you can say for now, but I'll show you what they are actually. So time complexity is big of n square. Space is big of 1, excluding output. So here, brute force versus optimal insight. What is wrong here? Repeated multiplication, okay, that's our main problem. We calculate the product of 2, 3, 4 for position 0, then partially recalculate for other positions as well. Let's say, what was here? Here it was 1, 2, 3, 4. Okay. So if the items were 1, 2, 3, and 4, 0, 1, 2, and 3, positions are there. Okay. Once we calculated the product of 2, 3, 4. Okay. Then we calculated product of 1, 2, 3 as well. First for this position, then for this position also. In this position, we calculated for product of 3, 4 again and 1 also. Correct. For this position, we calculated the product of 1, 2 and 4 again. And see, you can see a lot of overlaps. Too many repeated calculations here. So that's why it is not very optimal. Okay. Problem number 2, no cumulative memory. अब क्या है? Every time we are recalculating, but we don't remember. Correct? Doesn't remember that left products and right products can be reused. We don't remember, that's why we can't reuse them, the previous calculations. Inefficient pattern. Naive approach misses a mathematical structure. Obviously, without mathematical pattern, you will be recalculating. है ना? ये recalculate हो रहा है. Always calculating. Okay. Now, optimal insight क्या बोलती है? Optimal insight is nothing but all about reusing already calculated values. That's all. That's how you avoid recalculating. Okay. So as for any item, you understand that let's say 1, 2, 3, and 4 are the items in the array. Let's say we have a bigger array. 5, 6 are also the items in this array. Correct? If I were to show you the visually you can see that 0, 1, 2, 3, 4, and 5 are the indexes of this array. So let's say if I'm at index 2, okay, for this particular index, what will I do? I will calculate the product of items in left hand side. I will calculate the product of items in the right hand side. Correct? That would give me the answer for this index. For this also, left hand side and right hand side. For this also, right hand side and then left hand side. You can see. So these left and right is what I am gonna call the prefixes, है ना? Left को prefix बोल देंगे and the right को suffix. So suffix is which comes later, prefix which comes earlier. Okay. So the answer of I would be prefix of I and suffix of I multiplied with each other. So if I were to talk about this fellow, index 2, then I can say prefix of 2 would be, prefix of 2 would be, answer for 2 would be prefix of 2, which is this much, multiplication of these people, and suffix of 2, which is this much, multiplication of these people. Okay, that's what we are gonna move into this direction. Okay. So for any position I, left product would be nums 0 till I minus 1. Right product would be I plus 1 till nums n minus 1, last item, है ना? And the answer would be left product into right product. This is the, you can say, broken down thing of the whole formula. This was the hint for you to think in this direction, like what else you can do to achieve this prefix and suffix without recalculating, you know, without achieve this without recalculating, you know. Now let's try to see further. Optimal approach is, देखो, because we can't use any extra space, so we are gonna use answer array, है ना, answer array for our passes. Passes में क्या हो रहा होगा? As this particular thing suggested you, find the left product, multiply it with the right product. Correct? If I already have the left product, I can multiply it with the right product always. है ना? एक बार देख लेते हैं यहाँ पे. Like here, I have 1, 2, 3, 4. So 0, 1, 2, and 3. Let's say I have this answer array now. So same size 1, 2, 3, and 4. Okay. Let me make it bigger because I'm gonna rewrite override. Sorry, 1, 2, 3, and 4. Okay. Indexes are gonna be 0, 1, 2, 3. Let's say if I chose the left products, है ना, left products or prefixes in this, मुझे क्या मिलता है फिर, है ना? Because for this particular index, what is the left product? कुछ नहीं है, one only. You can't say zero, otherwise वो right को भी जब multiply करो तो zero हो जाएगा. Okay, so left is zero for this. For two, what is the left product? One, there was one only. For two, what is the left product? One only, है ना? चलो ठीक है, अभी मान लेते हैं. For three, what is the left product? Can you say two only? नहीं ना. Left product of three would be what? This 2 multiplied by its left product. So 2 multiplied by 1 equals to 2. Okay. For this 4, what is will be the left product? See, till 3 we know the left product was 2. So for 4, the left product would become what? 3 multiplied by this fellow. So 3 multiplied by 2 is equals to 6. Okay. These are the left products. 1, 1, 2, and 6. Now, ये first pass हो गया. For our passes है ना. So first pass we have calculated the left product. Okay. Now, look at this very, very carefully. Traverse this array in reverse order for the right products. Because for this 4, do I have the left product or not? All the left products or not? For this 4, do I have all the left products or not? है या नहीं है? Yes or no? 0, 1, 2, and 3 index. Yes, here if I were at the last index, then for this item 4, we have all the left products. So how can I put here the value of right product also? Obviously for the farthest item right hand side, what is the right product for 4? For this item right product is, let me write here, right prod, है ना? क्या होगा? Initially 1 ही रहेगा. So can't I put here 6 multiplied by 1 which is equals to 6, है ना? Update कर रहा हूँ. 6 multiplied by 1 equals to 6. Okay. And now I am gonna move from right to left, है ना? तो मैं second index पे जाऊंगा. But while moving to second index, what do I need to do? What do I need to do? See, for even second index also, I have the left product at the second index of the answer array, है ना? But I need right product still. So what would be the right product for second index? Obviously, whatever is there here, na? 4 is there. Before 4, what is the right product? 1 था ना? So just multiply it by 4. Before moving to second index, you will get 4. So once you move to second index, you have left product here, right product here. Just to do this multiplication is equals to 8. You have got, है ना? Then again, before moving here, just to do what? Update it again. 4 multiplied by this item was what? 3. It will become 12. So now if you move to the previous item, in the left hand side, so you are at the first index, item is 2. For this 2, you have the left product, you have the right product in this variable. What are you going to do? 1 multiplied by 12. You are going to do what? 1 multiplied by 12 equals to 12. Correct? Before moving further, what are you going to do? 12 multiplied by 2, this particular fellow. it will give 24 and then move to the next item or index, which is 0. For this 0, what is the left product? 1 was already here, right? We have calculated. So 1 multiplied by 24 will give you 24. This way, in the answer array itself, without using any further extra space, we have been able to calculate the both left and right products for any particular item in two passes. First pass was left to right, second pass is right to left using one more extra variable. So is it the answer or not? Let's check. आंसर क्या आ रहा है? I have shown here as well. यहाँ पे भी है. Answer is 24, 12, 8 and 6. 24, 12, 8 and 6. Same answer. Yes or no? Now it's quite intuitive है ना? Maths ने इसको कितना simple कर दिया है. Applying the mathematics for the pattern, it has become quite easy now. So that's what I have written here as well. Understand the pattern. Each answer I is product of left elements multiplied by product of right elements. Two passes I approach. First pass, compute left products for each position, which we done already. 1, 1, 2, and then there was 6. Then second pass, from right to left, है ना? Second pass हमारा right to left चला था. In this, compute right products and multiply with left products. So space optimization is there. Use output array to store left product and then update with right product in second pass. That's all. कोई और एक्स्ट्रा स्पेस नहीं यूज करना है. एल्गोरिथम आउटलाइन, initialize answer array with left product. Okay, let me show you. Use running variable for right product, second pass, multiply left product with right product and then return final answer. So let me show you this, है ना, very quickly. क्या करते हैं, इसको नीचे ले आते हैं. Let me just bring it down and let's have a copy of this also. Okay, so that we can run a code on this. यहाँ पेस्ट कर दिया. Okay, index is 0, 1, 2 and 3. Now here you can see, and we have calculated for the length of this array. We have created an answer array having 4 items, 1, 2, 3 and 4. Okay, 4 items are there, 0, 1, 2 and 3 index. Okay, done. Now calculate left product and store in answers. But for this leftmost item, what is the left product? It is only 1 only. If you put 0, then multiplied by left and right, it will become 0. No? So 1 put कर दिया. Now what? Now if I start to calculate the rest of the left product from here and move here, what will I be doing? For 2, left product would be left product of this fellow and this fellow itself, है ना? 1 multiplied by 1, 2 हो गया. If I move forward, for 3, left product of this fellow, which is 2 till here, and then multiplied by 2. 2 multiplied by 2 will become what? क्या जाएगा? Actually, I miswrote there. Why? Because though I am doing it from here, but I put value from the previous part. Just correct. Let me correct it. For this 2 and index 1, what is the left product? Correct. Left product means previous item and its left product ka multiplication. So 1 multiplied by 1, 1 only. Now if I come here, index 2. For this 3, what is the left product? Previous item and left product of this item, which was 1. So 2 multiplied by 1 equals to 2 ho gaya. Okay. As you can see here as well. I equals to 1, I less than I plus plus. Left product of I for I equals to left product of I minus 1 multiplied by nums I minus 1. That's what you need to focus upon. Okay. So answer of I equals to answer of I minus 1 multiplied by nums I minus 1. That's what happens here. Now for third index, answer of 3 minus 1 equals to 2. Second index, which is 2. Okay. 2 multiplied by nums I minus 1. So I is 3. 3 minus 1 equals to 2. Nums 2 is 3. 2 multiplied by 3 equals to 6. So 6 would be kept here. Now you can see, in one pass, in the answer array, I have put the left product of all the items 1, 1, 2 and 6. Now what? Step 2. Right product, this is a variable है ना, rp, let me call it rp is equals to 1 initially. Now for int I equals to n minus, you can see clearly we are starting from the last item. Okay, we are starting from the last item. We are starting from the last item 0, 1, 2, and 3. We are starting from here. Multiply left product already in answer array with the right product. Okay, so answer I equals to answer I multiplied by, because this is gonna give you the left product. Okay, ये मिल रहा है आपको, and multiplied by right product which is in the variable. So 6 multiplied by 1 है ना, वो 6 ही रहेगा. Okay, then I minus minus. Okay, multiply कर लिया, but before I minus minus I am updating it the right product variable as well. Would be what? Right product multiplied by num psi. So it was 1, because for this particular value right product would be what? 6 multiplied by 1 है ना, multiplied by 6 कर दिया, 6 आ गया. So now we will be moving here. Once we move here, again क्या करेंगे, answer I equals to answer I multiplied by right product. So 2 is having the left product which is answer I, right product is 6, 6 multiplied by 2 is equals to 12 है ना, or what will it be? 6 multiplied by 2, what will it be? 12, exactly, correct. Or have we put something different? There's one mistake. See, that's why dry run is very, very necessary. Though we are working with two arrays, you know, but this array is answers array, correct? 6 was the left product, not the right product. Right product was stored in this variable 1. And when I move from here to here, in this array as well, here to here, so obviously for index to right product would be whatever is in the right hand side. So I need to work with the nums array, not the answer array. Correct? Not with the answer array. So instead of multiplying 6, this would be 4. है ना? तो ये 4 आ जाएगा. So that's why when I am at the index 2, left product is 2 and right product would be what? 4. So 4 into 2 will become 8. Now this is good. Okay. 8 हो गया. Before moving further, again right product would be updated. Right product would be what? अभी तो 4 था. Now, before moving here from 2 to 1 index, I will multiply this 3. 4 multiplied by 3 equals to 12 हो गया. Okay. Now I will move to the previous index in the left hand side. I will come here. यहाँ क्या है? For this fellow 2, left product is 1 and the right product is 12 already. As you can see here. Okay. So 2 multiplied by 12 become 24 है ना. नहीं, 2 क्यों मल्टीप्लाई होगा, यहाँ तो 1 ऑलरेडी है. एग्जैक्टली, दैट्स वेयर पीपल कंफ्यूज मोस्ट. यहाँ 2 था, दिस इज आइटम, बट for this item we need to multiply left product and the right product. So left is 1 and the right is 12. So 1 multiplied by 12. Now you are correct. Yes, now you are correct. So 1 multiplied by 12 would be 12 only. This is the correct part. Okay, so 12 यहाँ put हो गया. But before moving from here to here, क्या करेंगे अभी हम लोग? Again, update our right product variable. So 12 था, here it was 2. So 12 multiplied by 2 will become 24. Correct? Now when we are here, for this 0th index, number is 1, left product is 1, right is 24. So 1 multiplied by 24 will give you 24 only. So now we have what? 24, 12, 8 and 6. 24, 12, 8 and 6. है ना? That's what you are getting. Okay? That's what you are getting as the answer. Correct? Exactly. Yeah, correct. So I hope this is clear till now. Okay. And let's calculate the time complexity now. Time complexity would be big O of n plus big O of n. Why? Because there are two passes. This one is order n This one also is order of n. So ultimately, big O of n only. Space complexity. Other than this answer array, we are using a few variables, so that would be constant as well. Okay. So this was all about this particular problem. I hope you must have understood it. Okay. Let's quickly have a catch. You can say comparison here. Time complexity 2 passes, order n each. So big O of n finally. Space complexity order 1 excluding the output. Okay. In brute force, it was quite slow, order of n square tha, but we were able to optimize it in place and order n time mein. Okay. So that was about this particular problem. It is a good solution. Okay. Now let's move to next question, which is rotate image matrix rotation. Okay. Why rotate image and then matrix also written here? Because images are mostly represented in the matrix form. Okay. So don't worry about this. कि सर मुझे पता नहीं image क्या होती है. कोई बात नहीं. Just for now, consider that images are represented in the form of matrix. Okay. So you are given the 2D n by n 2D matrix representing an image. You need to rotate the image by 90-degree clockwise. You know? 90-degree clockwise means if items are looking like this, then the items would be looking like this. You know? Like this. I'll show you, don't worry. Constraints, you must rotate the matrix in place. You need to do it in place, means same matrix में करना है. Do it in same matrix. Cannot use another 2D matrix, and by matrix always a square. This is a constant. A square matrix is given to you. So let's have an example. Consider this. Let's say array given is 1, 2, and 3, 4. This is a 2D array. Okay, 1, 2, and 3, 4 matrix is given. So after rotation, it would look like, okay. So if something is like this, it will be rotated, you know. So 1, 2 is here, and if something is like this, if you do 90-degree rotation, what will it look like then? है ना, ये ऐसे था. Now it will look like ऐसे. ठीक है. So 1 2 is looking like this. If we rotate it 90-degree means 1 2 will become like this. So 1 and 2. For 3 4 also 3 and 4. This was the, I mean, the you can say the common sense way of looking at this. And again, if you look at the output, is also looking like 3 1 in the first array, second array 4 2. Combined, it's a 2D array. That's how it will look like. Okay. One would be, है ना, 1 3 आपस में रिप्लेस हो जाएंगे, 2 1 आपस में रिप्लेस हो रहे हैं, है ना, 3 1 की पोजीशन ले रहा है. करेक्ट. एग्जैक्टली. यस. 1 2 की पोजीशन ले रहा है, then 4 3 की पोजीशन ले रहा है. That's how it is happening, but you don't need to worry about right now. Patterns we'll talk about. Obviously you can see that if you want to do it in place, you need to have some pattern. You need to find some pattern here. Without that you can't do it. Okay, especially in place. But I will show you how to do it without in place approach also. Don't worry. Let's see for this matrix. 1 2 3 4 5 6 7 8 and 9. After 90-degree rotation, it will look like 1 2 and 3. This row will come here. This row will come here. 4 5 and 6. This row will come here. 7 8 and 9. Let's see if we are correct or not. Answer is 7 4 and 1. First array 7 4 and 1. Second array 8 5 and 2. 8 5 and 2. 9 6 3. 9 6 and 3. Exactly correct. So I hope you have understood the problem statement. Now what I am gonna talk about is, I just really want you to focus upon the pattern here. What is a pattern to solve this? At least let's go with the brute force approach first. है ना, वो क्या होगा? 0 1 2 0 1 2. The best way to visualize a pattern is to give everything unique ID. Na? So 0 1 2 0 1 and 2. These are the indexes. Na? I and J. This is also I and J. Row and columns. Okay. Now look at this. Before rotation, 1 was at 0 0. After rotation, 1 is at 0 2. है ना? 0 0 is at 0 2. 0 1 कहाँ पे है? 0 1 is at, means 2 is at where? 1 2. 3 is at where? 0 2. कहाँ गया after rotation? 2 2. Correct? 2 2 भी चला गया. For this 1 0 कहाँ गया? 1 0 was 4. 4 is placed at 0 1. 5 1 1 6 2 1 है ना? 0 1 1 1 2 1. For what? 1 0 था 4 का, then 1 1 and 1 2. 1 1 and 1 2 है ना? यहाँ देखते हैं थर्ड रो का. 2 0 कहाँ गया? 2 0 1 2 means 7 went from 2 0 to 0 0. 0 0. 2 1 कहाँ गया? 2 1 was 8. 8 went to 1 0. Okay. Then 2 2 is there. 2 2, where did it go? 9 went to 2 0. So if you look at the pattern, what I was telling you is after 90-degree rotation, and after 90-degree rotation, what is happening is this is row, this is column, this is new row, this is new column, na? R dash C dash, initial and final row and column values. You can see that what was the value of row has, है ना, वो कहाँ चला गया है? What is the value of row has gone to columns 0 2 2 1. Or let me show you in a better way, है ना? 0 0 1 1. I will show you that later, ना? वो पहले दिखाने वाला था, but I think let's first establish this. 2 and 2. Here also you can see 0 0 1 1 2 2 0 0 1 1 2 and 2. So can't I say after 90-degree rotation R dash जो है new row is nothing but new previous column? Yes or no? New row is nothing but previous column, है ना? So can I say that or not? New row is nothing but previous column because your previous column था वही तो new row हुआ है after the rotation. You can see, है ना? This is one thing. Now, if I were to write it like कि I, j transform होके 90 degree के बाद after transforming or after getting rotated 90 degree, where would they go? They would go, at least I can write j directly because let's say this is r, this is c, this is r dash and this is c dash, means new row new column. So r dash is nothing but old column, so that's why j I can write here. Exactly correct. Now for the what is the where is new column, what is the new column? Now let's see, that's how you find a pattern, है ना, by observing. So I will show you this row 0 items went to second column, है ना. Row 1 items went to first column, है ना, because it was in between. So can't I say after rotation first row went into last, or last, or can say n minus 1th column में convert हो रहा है? Yes or no? N minus 1th column में convert हो रहा है. That's why the formula here will become n minus 1 would give you the last column, correct? But second row किस में convert हो रही है? n minus 1 minus 1th column, एक और पीछे. That's why 0 was going to 2 and 1 is still going to 1, है ना? If you put 1, है ना, first row I को अगर 1 पुट कर दे यहाँ पे, इसका फॉर्मूला बनता है n minus 1 minus I. So n was here. What was n over? 4 था. 1, 2, 3. Sorry, 1, 2, 3, 3 था. So 3 minus 1 minus 1. It will become what? 1. है ना? That's why for row 1, new column is becoming 1 only. Okay, 1, 1. So their formula क्या हो जाएगा? Minus I. That's what it is getting replaced to. So what we are gonna do is our first solution for brute force is gonna be more like you can say not exactly in place है ना because हमें copy करना होगा because if we put directly I mean the transformation formula for 90-degree rotation would be I comma j would become j comma n minus 1 minus I. Okay, so if we replace directly then the previous information would be removed है ना ऐसा तो हो जाएगा like 1 2 3 4 5 6 7 8 9. Okay, so what we are going to do is we are going to this is our nums array na or can say matrix. This is our matrix 0 1 2 0 1 and 2. Let's have one more answer or result matrix है ना ऐसा करते हैं एक result matrix बना लेते हैं same size 3 by 3. Okay, 0 1 and 2 are the indexes. 0 1 and 2 are the indexes. What we can fill here is for ij put j comma n minus 1 minus I. Okay, so as we saw it on the previous page क्या था 0002 पे जाया था है ना. So all the entries from here will become like let me copy this and paste there and let's paste it here. Yeah, so now you can see this. If I were to fill it properly क्या होगा 00 will go to 02. 02 is here so 1 will go here है ना. Then 01 will go to 1 2. 01 is 2 will go to 1 2. 1 and 2 is here so 2 पे आ जाएगा. Okay, similarly 02 will go to 2 2. 02 is 3 will go to 2 2 is here this place so 3 will go here. As you can see if I do it in the same matrix this 9 would be replaced by 3 so then I will lose 9 है ना तो वो एक issue हो जाएगा. That's why I need different matrix here. I know that it is not in place but I just want to show you this approach also. Later after this we will come to the in place solution. Similarly after 1 2 3 4 5 6 would come here. Okay, and then after that yeah 1 2 3 have come here. Okay, 4 5 6 have come here. After that 7 8 9 would be here. 7 8 and 9 would be here. Okay, so that's how things are happening. So what I am focusing upon here is you just need to have this use this formula because we have found it after observing matrix, create one more matrix named result and 2D array, put the answer there and then copy it back. Copy it back position by position. That's all. That's all you need to do. Copy तो आप कर लोगे, correct? You don't have to do much. So copy करना है वहाँ पे, है ना? So let's see here. The code is also, and we are taking the length. Then we are getting a new matrix of size n by n, a 2D array with I and j variables. I am tracing the whole 2D array. For rotation clockwise, ij will be converted to, or you can say position to j n minus 1 minus I. Okay. So in j n minus 1 minus I position, we are putting ij items. That's all. Nothing else. And once that is filled, we are copying it back to the original matrix. Though it is violating in place requirement, but yeah, for the sake of solution, for showing it, I am showing it to you. Okay. Two loops and we are just copying as it is item by item. Okay, time complexity for this would be nothing but big of n square plus big of n square है ना, दोबारा कर रहे हैं, so big of n square only ultimately. Space complexity, of course we are not doing it in place, so big of n square as well, because we are using a 2D matrix. Okay, that's why it is not too much, you can say, feasible for here according to the present state, but let's see आगे क्या कर सकते हैं. So obviously it violates the constraint of extra space, n square use कर रहा है. Not truly in place, requires copying back, inefficient order n square operation. So what we can do then? Challenge, we need to swap elements in such a way that we don't lose any values during the rotation process. है ना? That's what happened here actually. Actually, we found a pattern, but if we were doing it in the same array, then we were losing the item. Like one, if we put one according to this formula, then we will lose three. है ना? Three lose हो जाता. So that's why that's the main challenge for us कि कैसे करेंगे फिर. Now let's have a key observation. क्या key observation है? Let's see from the previous page. The observation is, let me copy this and put it there. Let me show you the observation. I was talking about mathematical equations, correct? So some mathematical observation is transposing it, step one, transpose diagonally, and then reverse every. So ट्रांसपोज डायगोनल क्या होता है, डायगोनली आइटम्स जो होते हैं स्वैप हो जाते हैं. लाइक इफ आई हैव 1 2 3 6 7 8 and 9, so if I were to take the transpose, है ना, it will look like transpose diagonally, है ना, so one, there is nothing on the diagonal of 1, so 1 would be what, 1 यही रहेगा. Okay, now these 4 and 2 are diagonally there, so their transpose would be what, 4 comes here, 2 comes here. Next, 7 and 3 would be transposed, है ना, swapped diagonally, 7 and 3. Now, once this row is completed, I will come to next row because till here things are done. So I will start from here, है ना, next item से. From here, 5 के diagonal में कोई नहीं है. Okay, for this position to start ना, starting position में यहाँ पे 1 के पास भी कोई नहीं था. Similarly, if I starting from here, 5 के पास भी कोई नहीं है. 5 would be 5. For 6 and 8, swap 8 and 6. For 9, है ना, यहाँ पे अब कोई नहीं था, फिर यहाँ पे आ गए. For 9 it is the only item, so 9 would be here. You can see the diagonal swap. क्या बन रहा है, ऐसा बन रहा है, like this it is happening. And once it is transposed, after that reverse every row, है ना, reverse every row. What I am doing, if I reverse row number 1, 7 4 and 1 would be there. Row number 2, 8 5 and 2. So row number 3, 9 6 and 3. Then I am getting what? I am getting the actual reversed array, reversed matrix. Yes or no? Sorry, rotated matrix, 90 degree rotation. That's what is happening. So we are gonna move with this approach. First, we are gonna transpose the matrix, swap across diagonals. Okay, then reverse each row. That's what we are gonna do. So in swapping, what is happening? 0 1 and 2, 0 1 and 2. है ना? I comma j is going at j comma ith position. That's all is happening while transposing. है ना, 0 0 0 0 पे गया है ना, आइटम इज 0 1, तो कहाँ पे गया है, 1 0 पे स्वैप हुआ है. 0 1 is swapped at 0 1. That's why you have seen 4 gone to 0 1 and 2 gone to 1 0. Similarly, for 0 2, 0 0 swapped to 0 0, 0 1 swapped to 1 0, 0 2 have been swapped to 2 0. Okay, That's what has happened. 02 was 3, 20 was 7. They have been swapped, correct? Similarly, if I start from, I mean, next row again and leaving was one item because I need to go to diagonal. Next row will be starting from 1 comma 1. Would be swapped by 1 comma 1. Then this is 1 comma 2. 1 comma 2 would be swapped by 2 comma 1. So you can see 1 comma 2 is nothing but 6, 2 comma 1 is nothing but 8. So 6 and 8 have been swapped, है ना? ये हो गया था. Then after that, is there any other item? No. है ना? Go to next row and now we have 2 comma 2 only. This will be swapped with 2 comma 2 only. So 9 was swapped with 9 only. Nothing else. है ना? यहाँ से ऐसे आए थे लोग. After reversal would be very easy. So let's see the solution here. That's what was happening. And I think I just need to show you this from here. Yeah, that's what we're doing. And I can copy this completely. Yeah, so this is how it is now. As you can see, what I'm doing, matrix I am taking the n as the length of the matrix. Okay, I'm first transposing, doing what? Swapping ij with ji position. Okay, swapping ij with ji position. Swap I comma j with j comma I. Nothing else, है ना? You know the principle of swapping. एक extra temporary variable लेना पड़ता है so that you don't lose the item, correct? Once this whole thing is done, transpose is over for step one. Then we are reversing each row. Again, for every row, we are putting one more loop, which is going till n by 2 only. Okay, and it is doing what? It is just reversing means swapping, nothing else. I को I and n minus 1 minus j पे swap कर रहा है. I don't think that I need to tell you here at this point how you swap, right? You can write the swapping logic. This is my swapping logic. Okay, linear swapping. Like 1 would be swapped with 7. Then 4 is at the middle, it won't be touched. So 7 and 1 would be changing their positions. Then 2 and 8 would be swapped. And a first item with last item. In a row swap, that's how you reverse, na? To reverse first item with last item, second item with second last item, and so on. That's what is happening here. Okay. So ultimately, this fellow is taking n square time. This fellow is also taking n square time. So the time complexity would still be big O of n square plus big O of n square, which is ultimately big O of n square. But space complexity would be what? Because we are not using any extra 2D matrix, okay, 2D array. So big O of 1 only, constant only, because of the variables that we are using. As you can see, what are the variables I, j, n is there, temporary variable is there, that's all. So that's how we are achieving. So I hope you must have been able to see and observe how you can on the advanced transformation level by observing the, I mean, how you can solve this kind of questions by observing the mathematical patterns. Okay, so little knowledge of mathematics is really required in DSA, not much but at least a little. Okay, so that's how you solve these kind of questions. Okay, complexity analysis, again same thing that we have talked about. Or n square, space is constant. Now let's talk about advanced pattern. So here, when to use prefix suffix, we have talked about two main things. Prefix and suffix, we have talked about the computations and then in place matrix transformations. So for prefix suffix, the identifiers are more like product of array except self, the question we have solved. Trapping rainwater also we did this. Some pre-calculation was there. And then maximum subarray problem is there. Then use running variables for cumulative calculations. That is the key of thinking about these things. Next is in-place matrix transformations. So rotate images, one question. Set matrix zeros is also one question. There are different kind of question. Spiral matrix is there. So if you work upon these, you will understand how you can work with the in-place, or you can say you can practice a little better on these kind of questions to get the idea of in-place matrix transformations. Okay. इंटरव्यूज में कैसे क्वेश्चन आते हैं मोस्टली फॉर द गूगल दे हैव आस्क्ड प्रोडक्ट ऑफ एरिया एक्सेप्ट सेल्फ टुडेस प्रॉब्लम जो हमने डिस्कस किया rotate images with different angles 90-degree was the starter. Okay, then there's 180-degree, then there's 270-degree as well. You need to find the pattern and you need to code that pattern. Simple है. Find the pattern and further code the pattern. That's all. Set matrix zeros. Okay, similar in place thinking. Meta, spiral matrix generation, diagonal traversal of matrix, value Sudoku checker. This is also one of its kind question. This probably you can learn in a better way when you apply DP and backtracking. Okay. In Amazon, maximum product subarray builds on product thinking, and then search in 2D matrix, sorted matrix problems में आता है, game of life आता है, then Microsoft variations, rotate array, 1D version, image smoothing algorithms, matrix block operations. So all these kind of variations have been asked in the big tech companies for the interview. So you can probably work around it and practice on these questions. Now, homework and practice plan. So obviously to build the foundation on such concepts, you can first start with implement both problems with detailed comments, then test with authoritative examples, try run with custom test cases, implement alternative approaches. Okay, because let me leave you with one thing. The matrix transformation that we just did, there is one more way. There is four layered approach also. Okay, four layer swapping for every item is happening. So I would say try to figure it out and try to apply it also. Okay, don't just stick to this approach only. Obviously, for multiple problems, there are multiple approaches to solve it. Okay, application build confidence. So you can solve next set matrix zeros in place matrix modification होता है इसमें. Spiral matrix layer by layer thinking is there. It takes it is gonna take you, I mean, for the beginners, enough practice, है ना? Lots of practice. It is gonna take to understand how things actually, because uh, it really challenges your visualization capability. Okay, आपको यहाँ पे visualize करना ही पड़ता है. Then only you can solve it. Otherwise, no. You will just remember it, and once you will, after some time, you will forget it also. Maximum product subarray, product optimization. Then for the mastery, you can go for these problems, game of life on LeetCode, search in 2D matrix, 2 sorted matrix search होता है. Diagonal traversal, advanced index mapping is there. I will say first try to stick to these things, okay? Now, for the next session, it have been a great session today. You people have been a great audience. So I would really like you to keep up the tempo, okay? And keep moving forward, keep practicing so that we can achieve the whole mastery around these things, at least to the level that you can crack the interviews. So in context to this, for the next session, I have planned to introduce some problems which where you can say binary search is applied and which are most frequently asked as well. So find peak element is one of the most frequently asked questions around binary search on arrays. And next is the search in rotated sorted array. Okay, this also I will be discussing in my next session. Okay, why this matters is binary search appears 60% of array interviews mostly है ना सब में आता ही आता है. A very very optimized algorithm you will see. I mean you will be amazed by the magic of this algorithm. Okay, how it impacts on the time and space complexity. Builds on our optimization thinking, essential for technical interview success and real application data search and retrieval. Real world में हमेशा ही होता है. Even Google search, any kind of search mostly uses this searching algorithm. Okay, so this is a miracle you can say. So people, that's all for today. And if you really like our session, if it is meaningful for you, which keep you enabled for the interview practices as well. So please do like, share, and subscribe, and do join the next session. Meanwhile, just keep practicing. Okay, so that's all for our session. Thank you.